I will just start with the recapitalization of the formulas of the results which we have already done in class 11th. I hope you know that I'm just writing down the some of the standard derivatives which you already know. The first one is derivative of constant. I hope this is the symbol of d by dx, that denotes the differential coefficient with respect to x, and this is going to be 0 for any constant. Then we have derivative of e to the power x, that is e to the power x only. Then we have derivative of a to the power x, that is a to the power x log a, where a is a positive number. Okay, then we have derivative of x to the power n, that is a algebraic one, which is nx n minus 1. Then we have the trigonometric formulas, that is derivative of sin x, that is cos x. Then we have derivative of cos x, which is minus sin x. I hope you all remember these formulas which we have done in class 11th. You should know the basic 10 formulas which I am just stating. Rest I will just show you the product rule, quotient rule, and how these formulas will be applied. Then we have derivative of 10x. Now this derivative of 10x is secant square x. Then we have derivative of cosec x. This is minus cosec x cot x. Okay, then we have derivative of secant x, which is secant x tan x, which is secant x tan x. And then we have derivative of cot x, which is minus cosecant square x. Okay, and then we have derivative of log x, which is going to be 1 by x. So these are the standard 11 derivatives which you should know. These are the basic formulas. There are 6 trigonometric ones, and then we have constant function, exponential, and a to the power x in the same class, and then x to the power n and log x. So these are the 11 formulas which we have already done. Actually, in class 11 we have derived these formulas using the first principle method, that is the basic definition. In this topic in class 12th, we are just going to apply them. So you should know the basic formulas. These are the 11 basic formulas. I hope you have all noted down. Now along with this, we have done some rules, beta, rules of derivatives. So what are those rules? I'm just quickly revising those rules also. Rules of derivatives. So the first rule was the sum rule. What sum rule says, if f and g are two functions, then the derivative of f plus g is derivative of f plus derivative of g. I hope you know the symbol dash or d by dx or dy by dx. They are all the symbols which denotes the derivative. F dash x or dy by dx or d by dx, they are all denotes the differential coefficient with respect to x. Okay, similarly we have the difference rule. Difference rule says that the derivative of f minus g is equal to derivative of f minus derivative of g. Then we have the product rule, which is very important. If we have product of two functions, that is f into g, then the derivative says it is f g dash plus g f dash, and this is very important. Please mention in the bracket that this is the product rule. Okay, similarly we have the quotient rule. This is f by g. Obviously f by g should be well defined, that means the g should not be 0. In this case the rule says that it is g square in the denominator, then we have g f dash minus f g dash, and this rule is known as quotient rule. So these are the some specific rule which you should know that. And you know the scalar multiple rule also, that is alpha f derivative is alpha times derivative of f, where alpha is a scalar. Okay, so these are the 5 basic rules of derivative which you should know. Okay, that how to find the derivative of sum, product, or difference, quotient, scalar multiple. These are the formulas which we frequently use in class 11. We can see some of the application of these rules. So let us try to do some of the question. Suppose for example he says that find derivatives of following. find derivatives of the following. So he says that in the first case find the derivative of x cube cot x, and in the second case find the derivative of x plus sin x upon ex plus 1. Okay, so these are the two questions which will include the derivative of exponential, trigonometric, algebraic, also the product rule, quotient rule, sum rule, all are included in this. So now how to start with the solution. So if you see that you have to find the derivative of this x cube cot x. So firstly try to observe that if I take this as f, this as g, then this is actually the product of f and g. So I have to find the derivative of the product. So obviously the product rule is in the picture. Now if you recall the product rule, what your product rule says, that f as it is into derivative of g plus g as it is into derivative of f. I hope this is clear. Okay, so this is equal to x cube minus cosecant square x plus cot x, and derivative of x cube will be by the formula x ki power n. What was the formula? It is nx n minus 1. So it is 3 into x ki power 3 minus 1, that is 2. So this is your answer. That is, you can take something common. Obviously x square is common. So it will be minus x cosecant square x plus 3 cot x. So this is your final answer. I hope this is clear to each and every student. Now similarly, if you look at the second one, this is your first problem. Now if you look at the second one, it is finding out derivative of x plus sin x in the numerator and e to the power x plus 1 in the denominator. So if you just compare this, then this will give you of the type f by g. Okay, this is a function of the type f upon g. So obviously in this case the derivative says it is g square. Okay, and then in the numerator it is g f dash minus f g dash. I hope this is clear. I have just applied the definition of quotient rule. Now you know that this derivative, just see what is the derivative of x plus sin x. It is derivative of x, which is 1, plus derivative of sin x, which is cos x. Similarly, what is the derivative of ex plus 1? It is derivative of ex, which is ex only, and derivative of 1, which is 0, because 1 is a constant quantity. So just replace these values, x plus sin x whole dash and ex plus 1 dash here, and take something common, ex plus 1, cancel with the denominator, and just try to simplify the expression. This will give you your final answer. I hope you are able to recall what I am saying, that how to apply product rule and quotient rule in various application based problem. Now this is something which we have already done in class 11. Till now I have just revised the concept, the formulas, the rules of derivatives which we have done in class 11. Now in class 12th we are starting with the first topic, that is known as chain rule. So I'm going to start my discussion with chain rule. That is, what is the meaning of chain rule and how this chain rule will be applied in various problems. Now there can be a 1 marker based on this concept. So this is known as chain rule. Okay, now what is this chain rule is that he says that if I have a function, say fx is equal to sine of 2x plus 3, okay, and I am asked to find its derivative with respect to x, its first order derivative with respect to x. Now as far as sin x is concerned, we know how to obtain the derivative. We know the derivative of sin x, but here in place of x we have 2x plus 3. So what is the problematic quantity here? The problematic quantity is this 2x plus 3. So what you will do, you will assume this problematic quantity as sin z. That means you will assume this problematic quantity as z. So now you will treat this function as sin z. Okay, now you will treat this function as sin z, where z is 2x plus 3. Now what your chain rule says, Now normally differentiate this sin z with respect to z, that is going to be cos z into, you have to multiply by the derivative of z. This is what chain rule is all about. That is, whatever is the troublesome quantity, let us assume it to be z. Now this function becomes sin z. We know the derivative in normal cases for sin z, it is cos z, but chain rule says that whatever you have assumed as z, you have to multiply by the derivative of that. This is called chain. So now if you just replace the value of z, what you will get, it is cos of 2x plus 3 into derivative of 2x plus 3. Now by the sum rule, I can just find the derivative of 2x plus 3. So this is cos of 2x plus 3, and the derivative of this is 2 into derivative of x, that is 2 into 1, and the derivative of 3 is 0. So the final answer will be 2 cos 2x plus 3. I hope you're getting my point. So this is how you will find the derivative of 2x plus 3. This is your chain rule. Chain rule is actually, if your function is given in some other variable, that is, if the function is, f of z, and you're trying to find the derivative with respect to x, okay, that is differentiate, find f dash z with respect to x. So what your chain rule says, that you just find out the derivative of f with respect to z and then multiply it by dz by dx. This is what your chain rule is all about. Okay, that is, if your function is given in terms of z, in the variable z the function is given, but the derivative is asked in with respect to x, then the chain rule says you just differentiate f of z in the normal case, and then don't forget to multiply by dz by dx. This dz by dx is called the chain, and this is what I have done in this example. Let us see one more example. Now suppose he says that fx is equal to cos of root x. Find f dash x. Okay, now in this case I have taken my fx as cos of root x, and I have been asked to calculate f dash x. Now as you all know, we know the derivative of cos x, which is minus sin x. So what is problematic in place of x? This root x is the problematic term. So let us denote this by z. Whatever is problematic, just treat it as z. So this becomes cos z now. Now what I have told you, that if you want to find derivative with respect to x, normally differentiate cos z. The derivative of cos z is minus sin z, and then don't forget to multiply it by z dash. Now if you replace the value of z back, you will get it is minus sin root x into derivative of root x. Root x can be written as x ki power half. So x ki power half ka derivative. So this is coming out to be minus sin root x. And what is the derivative of this? It will be x half nx n minus 1. So half x ki power this. So it will be minus sin root x upon 2 root x. This is your final derivative. I hope you are able to understand a little bit about chain rule. I'll give you several examples to explain the concept of chain rule, but this is the starting, and I hope you are able to understand what I'm saying. Okay, so now let us do some more example. Now suppose we take in example number 3, he says that find the derivative of fx is equal to sine of cos x. Now I have taken function of function, so it is sine of cos x. Now when we take sine of cos x, again I'll go one by one. We know that the derivative of sine x is cos x. So in place of x, I have this cos x as the problematic quantity. So let us denote this by z. So this becomes your sine z. Now when you take its derivative with respect to x, so the derivative of sine z is normally cos z, and then don't forget to multiply by the derivative of z, that is z dash. So this becomes cos of z की जगह पे cos x into derivative of cos x, and you know that derivative of cos x is minus sin x. So final answer is cos of cos x into minus sin x. I hope you are able to understand what I am saying. So this is how you apply the concept of chain rule. Now let us see one more example. This is my example number 4. He says if fx is equal to under the root sin x plus cos x, find f dash x. Okay, so now we know that the derivative of root x is 1 by 2 root x. We know how to find the derivative of root x. It's a standard algebraic formula, x to the power n wala, which is nx n minus 1. So we know the derivative of root x. But here in place of root x, it is given as root of sin x plus cos x. So this sin x plus cos x as a whole is the troublesome quantity z. So we can take this sin x plus cos x as z. So now we can treat this function fx as root z, isn't it? So what will be your f dash x? It will be the derivative of root z in the normal case, that is 1 by 2 root z, into derivative of z, that is z dash. So just replace the value of z, that is sin x plus cos x, into derivative of sin x plus cos x. Now we know the sum rule, so this will be in the numerator. The derivative of sin x is cos x, the derivative of cos x is minus sin x. So numerator becomes cos x minus sin x, and denominator becomes 2 times root of sin x plus cos x. So this is how we apply the concept of chain rule in various different problems. I hope now you are able to understand what I am saying. Now we may have more than one chain involved in one particular question. That is, he can give you the question like this also, that find the derivative of fx is equal to sine of e to the power x. Just see, here I have given you chain of chain of chain. That means here three functions are involved, tan x, sin x and ex. So I'm going to give you the procedure one by one. So in the very first step, we know the derivative of tan x. So in place of x, we have this sine of ex as the problematic quantity. So let us denote it by z. Now I can treat this function as tan z. So my chain rule says my f dash x is nothing but it is derivative of tan z, which is secant square z, into multiplied by the derivative of z, which is z dash. So this is coming out to be secant square. Now in place of z, I will replace sine of ex, and now here you have to find the derivative of sine of ex. So this first chain is complete. Now concentrate on this quantity. Now again, I have to find the derivative of sine of e to the power x. Now we know the derivative of sine x. So here this e to the power x is the problematic quantity. So I have to again reapply the chain rule. So this goes as it is. This secant square sine of ex goes as it is. But what I have done, I have taken this as z. So now this becomes sine z. So the derivative of sine z is cos z. Again, you have to multiply by the derivative of z. Whatever you will assume as the problematic quantity, don't forget to multiply by the derivative of that assumed quantity. This is what the chain rule is all about. Now, this will be further equals to secant square sine of e to the power x, and then cos of e to the power x, and derivative of e to the power x is e to the power x only. So this is your final answer. So this is how you will apply chain of chain. So this is what I am saying, that there can be more than one chain also. So in chain rule, you have to just assume what is the problematic quantity, and then just term by term just differentiate this, and don't forget to multiply by the derivative of that assumed quantity. There might be the case where you have to apply the chain rule twice or thrice, so it will just make the question lengthy, but the concept remains same. That means you have to apply 2 chains or maybe 3 chains if the question is of 2 marks, 3 marks. But in the last, the concept remains same, that you have to do term by term differentiation, and that will give you the concept of chain rule. So I hope you are able to understand. I have given you 5-6 different examples of chain rule. Now you can attempt questions from your NCERT and exemplar book or any other reference book to give more written practice for this topic. In my next topic, I'm going to start with differentiation of implicit functions. Thank you.